Now that we have looked at the technological constraints, we can incorporate the economic constraints into the model and really look at the full problem of the firm. So let's look at what are the economic constraints for a competitive firm. Now, I'm qualifying the type of firm that it is because throughout this course we're going to study the behavior of many different types of firms that depends on what are the nature of the economic constraints that they face. And you will see a lot more about this after Unit 6. But for now, we're going to focus on competitive firms. What are competitive firms? Are competitive firms that are price takers both for output and for inputs. So in particular, we're going to assume that they sell at fixed price P. So every unit of Q that they produce sells at fixed price P. So this is per unit of Q. And then the inputs, they also have to be bought at fixed price, which is at wage W per worker, per unit of worker or labor, and at R per unit of capital. As you will see, this assumption is extremely important for determining how well markets perform. And we're going to study that in detail next unit. But for now, these are the economic constraints of the firm. It is a price taker in all of the markets in which it has to interact. Now, that leads to the following problem for the firm. Maximize over three decisions, how much to produce and how many inputs to hire, all non-negative, of Q times P. Notice that this is the amount of revenue for the firm, minus RK plus WL. Note that these are the costs for the firm. And it cannot decide to sell any quantity Q. It has to satisfy it such that Q is feasible and therefore is equal to FKL. The amount that is sold is exactly what is produced. Now, we're going to denote the solution to this problem as Q star of P WR, K star of P WR, and L star P WR. Notice that this is the supply of the firm and this is the demand for capital and labor. I want to make several remarks about this problem. Remark number one, notice that the firm is in several markets acting at the same time. It has to make decisions about how much to sell and how many inputs to buy. Second, notice that the decision about how much to do about capital, labor, and output may depend on the three prices. These things, the amount that you want to sell may depend very intuitive, not only about how you want to sell, but about the price of the inputs that determine the costs of production. Third, I've written the problem in the more general form because this will help us understand something in a couple of minutes, but please notice that in reality, we can use this equality constraint to substitute here, and you can simplify the problem simply as 1 over maximizer over inputs, and then once you know the optimal inputs, you know immediately from this equality the amount of output. In the rest of this video, I want to show you something very beautiful that is very subtle, but it will prove very powerful for the rest of the unit and later in the course. So it's very important that you make sure that you understand these ideas. Now, there are two equivalent ways in which we can study the problem of the competitive firm. What I want to do is explain to you what they are and why are they equivalent. So one way is to think of this, of the problem of the firm, as one of a choice over inputs. And I'm going to show that there is an equivalent way in which you can think of the problem of the firm as only of one of a choice over output. So instead of thinking of making the three choices simultaneously, as in the general version of the problem I just showed you, you can think of it as a simpler problem either over inputs or over outputs. So what does a choice over inputs look like? It's basically the general problem that we saw before, substituting the equality constraint. So this is going to be equivalent to maximize over K and L greater or equal than 0, PF of KL. Notice that F of KL is the amount of output, so again this is revenue minus the cost of the inputs, and there is no constraint now because it's already implicit in the revenue formula. From this you're going to get what is the optimal amount of inputs, K star of P of W and R, L star of P of W and R. That's the solution literally of this problem, but then you can get from substituting or from the fact that you know that output is just equal to the production that is achieved by capital and labor demanded, you just get that Q star, the amount supplied, is equal to, as a function of course of PW and R, just equal to F of K star comma L star. And I'm not going to write the prices to simplify the notation. Okay, so you know that there's a way in which you only have to maximize over two things when you think over the problem. It becomes a problem of how much do I hire to produce on my firm. Now let me show you the equivalent way. It looks a little bit more cumbersome, but bear with me because it's going to be incredibly useful. Here, the problem is we only want to worry about how much output to produce. But in order to do so, we have to split the problem into two steps. So in step number one, we're going to solve a problem of cost minimization. And in particular, we're going to ask the following. We're going to ask, what is the minimum that we need to spend in capital and on labor? Remember, this is the cost of any amount of capital and labor that gets higher with capital and labor greater than equal than 0, such that we can achieve a level of production Q. This is called a cost minimization problem because it literally says, given that I want to produce Q, what's the cheapest way of achieving it? Now we're going to call the cost function the solution to this problem. So C of Q comma WR is going to be equal to R times K minimum of Q given WR plus L times W minimum of Q WR. Now, don't be thrown off for the notation. When you solve the problem, you get the K and the L at which cost is minimized. That's K mean and W mean as a function of how much you want to produce and the prices. And then the cost is what is the minimum cost. This literally is what is the minimum cost at which that production can be achieved given the prices. Now, given that, we can move to another step, which is a step 2, which says we're going to maximize, we're going to choose how much we want to produce of P times Q, again this is the revenue, minus, now we don't have a cost function of that type, we know exactly what it costs to produce. It comes from the first stage, minus cost of Q given WR. And when you solve this problem, you're going to get the supply. Q star of P WR. So notice that in both cases you end up with the amount supplied, and in this particular case you did it by characterizing the inputs first. In this particular case you do it by maximizing your revenue minus your cost given knowledge of the cost function, and then if you want to know the input demand, you know the level that gets produced, so what you can do is you can back up the input demand, then you can get it just by saying what is, so basically L star of PWR, the input demand, is just going to be the amount that minimizes the cost, which is going to be L min of Q star, the amount that you produce given WR, and the same thing for K star. I want to finish this video making more precise the connection between the two formulations of the problem. In particular, I want you to notice that if you have profit maximization at Q star, K star, and L star, if that combination of outputs and inputs maximize profits for the firm, it has to be the case, it must be the case, it implies that K star and L star minimize the cost of producing Q star. Now, why does that has to be the case? Why? Well, remember that the profits at Q star are just P times Q star minus R K star plus W L star. Okay? Now suppose that K star and L star are not minimizing the cost of producing Q star. What does that mean? It means that we can find another combination, Q hat and L hat, that with two properties. First, Q star can be produced with them, and second, the cost of them, so our R K hat plus W L hat, is less than the cost of this. But that would be a problem, because then the following output, Q star comma K L hat, is feasible and has greater profits. So it has to be the case that this K star and L star are cost minimizing, because otherwise we can find a way of making better profits, which would contradict the fact that this is profit maximizing in the first place. So I hope that gives you an insight about the very tight relationship between profit maximization and cost minimization.